Good morning, friends. Today we'll start another new section. This is a third part of Parkinsonism. Let me show you. Today we'll see about the mechanism of action and how the dopamine is being circulated in the brain. And here I've drawn a diagram of brain which is indicating you different types of nucleuses present in it and which are used for different purposes. And let me finish off the diagram first and later we'll go to the mechanism of action. And here you can see different types of parts over here. I've indicated over here. So the first one over here is called as caudate nucleus. What it is called as? It is called as caudate nucleus. And just below the caudate nucleus, you can see three types of parts over here. Three different sections. One is triangle, the other two are rectangles shaped. So these are divided into both parts, that is left side and the right side. So whatever the picture is onto the right side, it is always has to be represented onto the right side. So both of them are there present here. So one, as I indicated over here, in one which is as one, this is called as caudate nucleus. And next we'll come to the second picture, which is numbered as 2 over here. So it consists of three parts. The first one is called rectangle. The second two are the first one is triangle. The other two are rectangles. So the first one, which is the triangular in shape, it is called as, I've indicated over here, globus pallidus interna. So what it is called as? Globus pallidus interna. So the triangle part which is present onto the both sides, that is called as globus pallidus interna. And just below your globus pallidus interna, you have one rectangle like structure over here. That first rectangle structure is called as globus pallidus externa. The one which is in the triangle in shape is called as globus pallidus interna. And onto the just below your triangle, you have one rectangle over here. That rectangle is called as globus pallidus externa. And just below your globus pallidus externa, you have one more triangle over here, and that is called as putamen. I have indicated over here. You can see the word here. Putamen. So, which consists of three parts over here. The first triangle is called as globus pallidus interna, globus pallidus externa, and the one is called as putamen. And all these three, that means the putamen, the globus pallidus interna, globus pallidus externa, in together, the three together is called as lentiform nucleus. What it is called? It is called lentiform nucleus. You can indicate all the three parts over here in with one word, what is called as lentiform nucleus. And this lentiform nucleus and the caudate nucleus, both of them are called as basal ganglia. What it is called as? Both of them is called basal ganglia. So here we talked about two nucleuses or two regions of the brain. The first one is caudate nucleus and the second one is called as lentiform nucleus, which consists of three parts. This is called as globus pallidus interna, globus pallidus externa, and the one is called as putamen, right? And just below the midbrain, this position is called midbrain, and just midbrain, just beside the midbrain, you have two types of semicircles here. Two circles you have seen here. These are called as thalamus. When it consists of two, they are called as thalami because plural sentence. So you can indicate it as thalami. One is called as thalamus. The two are together called as thalami. So the midbrain, which is in the center, and beside this midbrain, you have two types of semicircular ball-like structures, and that is called as thalamus. And both are in plural sentence, it is called as thalami. Next, and just below your thalami, you can indicate two more points over here. I am indicating over here. Those 2 points, that means those two drop-like structures which are present over here, is called as subthalamus. Just beside your midbrain and below your thalami, you have a region called subthalamus. What it is called? It is called subthalamus, right? And just below your subthalamus, you can see the large structures over here. Large like structures. I am doing it in green color so that you can understand the color. The colors just beside, just below your subthalamus, you have a large paired bean-like structures, and those two are called as substantia nigra. What are those called? Those are called as substantia nigra. And this substantia nigra is a storage place of the neurotransmitter called as dopamine. As we are talking about the Parkinsonism, in the previous two sections, we told that this dopamine is much responsible for the causes of Parkinsonism. And now we are seeing the structure. What is that structure called? It is called as substantia nigra. Here I am indicating over here with a highlighter. This is called substantia nigra. So substantia nigra is a storage place of, or the synthesis place of, dopamine. And now this is the responsible one which is causative for the Parkinsonism. So whenever there is a deficiency of dopamine, always the substantia nigra will be darkened itself. Why? Because the synthesis is not taken place, and all the area is getting more and more darker than the other parts of the brain or other nucleuses of the brain. So by this you can diagnose that the patient is suffering from the dopamine deficiency, and also we can conduct that this is related to the disease of Parkinsonism. So how we need to diagnose? By doing the transverse cutting of your brain, or you have to take the neurotransmitters from the substantia nigra, then we can understand that biopsy test, that we can understand that the substantia nigra became so darkened in color rather than the other areas of the nucleus, other areas of the brain. So we can understand that that substantia nigra has been blocked off without having any synthesis of dopamine, and so it is leading to Parkinsonism. So we have seen the different parts over here. The first one is caudate nucleus, the second one is called lentiform nucleus, the third one is called thalami, the fourth one is called subthalamus, and the fifth one is called substantia nigra. And just below we have done this. This is called the TS of spinal cord, where the messages are being sent forward. And also on the top of, that means on top of the head, on the top of all these, you can see here three small blocks over here. What is this area called? This area is called as primary cortex center. We know that the cortex center is the center. From there the messages are passed to the spinal cord, and from the spinal cord it is reaching to the various organ systems. And so we can know that the primary cortex center is the messagial center, where the collection and the dropping of the message has been done. And so this cortex is called as primary motor cortex. We know that there are two types of functions, motor functions and sensory functions. Though this Parkinsonism is related to the degenerative disorder, it is related to the motor dysfunctions. Why? Because there is a disability of limbs, there is disability of legs and feet. So we can know that this is a primary, it's a motor function, and so the top of the primary cortex is called as primary cortex motor center, or we can call primary motor cortex region. So this is the region where it collects the messages from the body and stored it, and it sends to the other parts of the brain for the answering of that question. And once again that question answer will be taken back to the cortex, and from the cortex it is passed to your spinal cord, and from the spinal cord it reaches to the various organs of the body. So here this dopamine is very good neurotransmitter which is responsible for the functioning of limbs and feet. And particularly we know that this area which has been on top is called as biceps muscles, and on the between, that means the inner region, it is called as triceps muscles. So in order to function of this biceps and triceps muscles, this dopamine is very important. Why? Because it is controlling the inhibition and excitation of both the GABAergic neurons and the glutamate neurons. So we know that the glutamate neurons are the neurons which are having a transmitter called as glutamate, which is always excitatory in function in the brain. And this excitation is being inhibited by another neurotransmitter what is called as GABA. And this we know that the GABA neurotransmitter is done in the GABAergic neurons, where it is used for the inhibition of the excitation what is created by the glutamate. And the DA, that means the dopamine, which is submitted from the substantia nigra, is controlling and making the enhancement of excitation of glutamate, and it is enhancing the inhibition of GABA. So what is the purpose of dopamine? Means dopamine is always just doubling your activity of excitation, and it is doubling the activity of inhibition, whether it is a glutamate inhibitors or glutamate excitatory neurotransmitters or GABA inhibitory neurotransmitters. And in order to know how this traveling of dopamine is being helpful for the inhibition and excitation, we need to know two pathways about it. One pathway is called as direct pathway, which I have indicated over here. You can see the direct pathway, and you have another pathway which is called as indirect pathway. I am indicating over here. So the transformation of neurotransmitter from the cortex area once again to the cortex area is done by two pathways. What is that pathways? The pathways is called as direct pathway, and the second one is called as indirect pathway. The direct pathway is called as corticostriatal pathway, and indirect pathway is called as niagral striatal pathway. The first pathway, that is the direct pathway, is called as corticostriatal pathway, and indirect pathway is called as niagral striatal pathway or striatal Niagara pathway. So you have two pathways. What are those two pathways? What is corticostriatal pathway? The second one is niagral striatus pathway. So two pathways. One is direct and the other one is indirect. Now we'll see what is the direct pathway, that is the corticostriatal pathway, and how it is helping for the transmission of excitation. So you just keep it in mind, we are traveling the messages from bottom of the body, particularly your biceps muscles and triceps muscles. And now here you take into consideration the triceps muscles. What is the work of triceps muscles? It has to do the work of inhibition and excitation. That means the biceps muscle has to turn the hand top and bottom. That means one contraction and one relaxation. So these two activities has to be done by direct and indirect pathway. The direct pathway is acting on triceps muscles, and the indirect pathway is acting on biceps muscles. So the triceps muscles are always in the excitation stage, and the biceps muscles are always in inhibition stage. That means the excitation is done by glutamate neurotransmitter of tricep muscles, and the inhibition is done by GABA neurotransmitter of GABAergic neurons. So two types of movements can be seen. One is the tricep muscles and the biceps muscles. So once you want to open or relax your hand like this, That means the triceps muscles is using for excitation. So if you want to get back once again your hand like this into the position, the bicep muscles are using, so which are present on top of bicep muscle. That means it is doing the inhibition. So you can understand a small point over here. What is it? Whenever you are doing this activity up and down, there is no rapid movements in it. So only just 1 and 2, 1 and 2. So only these two activities are being done. But if at all the dopamine, which is neurotransmitter, which is done in your substantia nigra, directly pouring its neurotransmitter into the direct pathway and indirect pathway, you can see the rapid movements of your muscles. How it is done? We can just finish off like this. You can do the rapid functions. So whenever you are doing this rapid functions, you can understand that the dopamine is doing its transportation onto the direct pathway and indirect pathway. That means one pathway is supported with the dopamine onto it. So dopamine is a neurotransmitter which is helping glutamate and GABAergic neurons in order to produce the rapidity of the movements, the speed of the movements, the uniformity of the movements. So this can be done by the dopamine. As I said here, the dopamine is a deficiency in Parkinsonism. So possibly you can see the sluggish movements of your feet, sluggish movements of your hands, and sluggish movements of all the parts of the body, particularly the eyes, the eyelids. Yesterday we were telling about that. Dysphasia, dysmonetia, hypomimetia. So these are different types of lessening functions because of dopamine deficiency. That means the substantia nigra has been, the production of neurotransmitter of dopamine is been lessly produced. Now we'll see. So you take into contact that the primary cortex, the first cortex, it receives its message from the spinal cord that it wants to make a movement onto the before. That means you have to take a hand before. So the cortex received its message. Now I am indicating you the message over here. This is a message to make one movement. That means the tricep muscles movement. So what happens? The primary cortex center is making its message directly to putamen. I have indicated over here. The primary cortex center, the motor cortex center, is sending its message to putamen. And once again, from the putamen, the message is sent to globus interna. From the putamen, the message is transferred to globus pallidus interna. And from the globus pallidus interna, the message is transferred to thalami. And from the thalami, it is being reached directly to the cortex after making its function to back to subprimary cortex. So this is called direct pathway. So once again I am repeating you, the message has been received from the muscles, that means the contraction of the limbs and the feet, and it is being received by the primary cortex center. And from the primary cortex center, the message is being transferred to putamen, nothing but lentiform nucleus, first part, what is called putamen. And from putamen, this message is transferred to globus pallidus interna. And from the globus pallidus interna, it is transferred to thalami. And from the thalami, the message has been received, and that message is being transferred to the primary cortex center, and directly it's sent to the spinal cord, through the spinal cord area via traveling the midbrain, and from the spinal cord it is being sent to the tricep muscles that one contraction can be done. So this is called as direct pathway. So the direct pathway is having four. One is primary cortex, to the putamen, to the globus pallidus interna, to the thalami, and back to the primary cortex. This is called direct pathway. If at all we want the rapid movements of this tricep muscles, so what happens? We need to draw the neurotransmitter of dopamine into the direct pathway. So we know that the substantia nigra is the house of dopamine. So what happens? The dopamine is being transferred itself and pour its neurotransmitter into putamen. That means where the glutamate having its transactions over here, stimulations over here. So this is a glutamate neurons which is doing stimulation function, and from here to here the GABAergic neurons are being taken into position where the inhibition starts, and this inhibition and excitation will starts to the globus pallidus interna where the inhibition has been done and it started stimulating here. In the globus pallidus interna, the GABA has been more and more released. So more the GABA, more the inhibition, and from that inhibition more and more the message has been sent to the thalami. From the thalami it has to send to the cortex center by the stimulation of the body. That means it is understood that it started with stimulation, it is start in between you have inhibition, and also you have later the excitation. So the message of excitation has once again reached to the primary cortex center, and that cortex center is sending the message to the spinal cord so that your tricep muscles are being excited. So this is the first movement, and this is done by direct pathway, and we need to know that it has been increased like this. How it is increased? The substantia nigra, which is a storage of dopamine, is pouring its neurotransmitters onto the GABA, and that GABA is being more and more inhibited over here. I am indicating you the dopamine synthesis within red color so that you can understand. The green one is GABA and here is dopamine, which is acting on the GABAergic neurons, and it is started inhibiting more and more, and once it reaches the thalami, it is being done by a GABAergic neurons here for more inhibition and doing the stimulation of that particular GABA neuron there, and from that GABA neuron it is reaching the primary cortex center, which is having more and more stimulation, giving you the more and more excitation. So the message of excitation has been reached to the primary cortex center, and from the primary cortex center it reaches to the spinal cord to send the messages to the tricep muscles for the doing of the function. So this is done by direct pathway, and the one which is pouring your dopamine synthesis on the direct pathway is called as D1 transmitter, D1 dopamine neurotransmitter. So this is direct pathway. Now we'll go to the second pathway, the functions of bicep muscles, how it has to be done. So in order to do the next function of your tricep muscles, coming back to the inhibition stage, it has to drop down one more pathway. That pathway is called as indirect pathway, and here you can see the diagram of here and just gave you here. The indirect pathway is done from the motor cortex. I am indicating onto the right side so that you can understand. Here once again it is reaching the putamen. From the putamen it is reaching the globus pallidus interna, externa. From the externa it is reaching subthalami. From the subthalami from subthalami it is reaching thalami, and from thalami it is reaching globus pallidus interna, and from globus pallidus interna it is reaching motor cortex. So indirect pathway is having two more junctional places. Just we'll repeat what it is. The indirect pathway is done starting from the motor cortex center, reaching the putamen. From putamen it is reaching globus pallidus externa. From globus pallidus externa it is reaching your subthalamus region. From the subthalamus region it is going to globus pallidus interna. From the globus pallidus interna it is reaching your thalami, and from thalami it is reaching your primary cortex center. If you are confused, just one second, I want to repeat you so that you will be won't having any other confusion. So the red lines are indicating you the passageway from the primary cortex to the top one. So the primary cortex is sending the message to putamen. From putamen it is reaching globus pallidus externa. From globus pallidus externa it is reaching subthalami. From subthalamic it is reaching globus pallidus interna. From globus pallidus interna it is reaching thalamic, and from thalamic it is reaching the primary cortex. So only two junctional places are much more attached over here than the direct pathway. So what it is? The indirect pathway starting from the primary cortex to the putamen, from putamen to the globus pallidus externa, from globus pallidus externa to subthalamus, and from subthalamus to globus pallidus interna, and from globus pallidus interna to thalami, and from thalami to primary cortex center. So once again it is reaching out here. Your glutamate neurotransmitters have been started stimulating, and this stimulation has been done of the neurons, and from these neurons it is been submitting to the GABAergic neurons which are present in externa, which is starting your inhibition. Why? Because it is GABAergic neurons, so there is less release of GABA onto the subthalamic, and from the GABA it is reaching to the subthalamus region where the neurons are once again stimulated, and so the once again stimulation is being given in your green over here, which is giving you the rapid movements, and it is reaching your globus pallidus interna, and into the globus pallidus interna it started once again the stimulation of GABAergic neurons, so the less of GABA has been produced, and from here less of GABA it is being reached to the thalamic by stimulating the GABAergic neurons, more and more inhibition, that means the greater of GABA, and once it is reaches your EPSP, nothing but the excitation, and once it reaches your GABA, your increase of stimulation has been done, and it is reaches to the primary cortex center, and from the primary cortex center it is reaching your spinal cord and to the bicep muscles, indicating you the next inhibition of your tricep muscles, what has been done before. This is the action of direct pathway, and this is the action of indirect pathway. So direct pathway, indirect pathway. So what is one done? Only one action is done, 1 and 2. So in order to repeat more and more rapidity, the dopamine has to be submitted over there. So what happens if at all dopamine is been submitted, we can start doing the rapid functions of these tricep and bicep muscles. So this is done by the pouring of substantia nigra pathway onto the indirect pathway to the putamen, where it is being received by the GABAergic neurons. So it is supporting the GABAergic neurons to once more and stimulation, so that it is receiving more and more stimulation and the GABA is released more. Once again if GABA is released more, you have more and more inhibition, and after reaching your thalamic it started stimulating your GABAergic neurons for the stimulation of GABA, giving you the IAPSP, and this from IAPSP it is going to the globus pallidus interna, where it is once again started stimulating. From the globus pallidus interna it is reaching your thalamus region for one more stimulation, and also from the stimulation it has started receiving to the motor cortex, where the stimulation is trying to release more and more. So that means the dopamine is enhancing the work of GABAergic neurons and the glutamatic neurons, so that the rapidity and the progress and the speeding of your work will be done whenever it is needed. So it is a work of dopamine. And in between you have one more neurotransmitter into the putamen. So what is that neurotransmitter? This neurotransmitter is called as ACH. We know that ACH stands for acetylcholine neurotransmitter. And if you see the work of neurotransmitter, what it is doing, it is controlling the work of dopamine, and it is controlling the work of GABA, and it is controlling the work of glutamate into the putamen to do their own activities. So that is controlling all the three activities. So it is just doing the opposite actions of dopamine. So if at all the dopamine is doing the enhancement and excitations and inhibitions of both the glutamate and the GABAergic neurons, the anticholinergic, that means the acetylcholine drugs, will always try to inhibit that situation, so that there is a neutral pathway both of excitation and inhibitants. So this is the work of ACH. So if you see the putamen, you can see 4 types of neurotransmitters doing their job over there. The first one is glutamate, which is doing the excitation function, and which is submitting onto the GABAergic neurons for the stimulation. Once the GABAergic neurons have been stimulated, it's starting the functions of inhibition, and the dopamine from the substantia nigra is pouring their neurotransmitters onto the direct pathway, that is the GABAergic neurons, to make the inhibition more and more enhancement, and from the inhibition it is going to the acetylcholine, which is doing just the opposite functions of dopamine, that is the controlling of your both excitation and inhibition, and enhancement of both excitation and inhibition of the dopamine. So the dopamine is just controlled by ACH. So if you see in Parkinsonism, there are two main difficulties. What is that? It is decrease of dopamine, that means the substantia nigra has been collapsed, and also the increase of ACH. So if at all there is no control of dopamine, glutamate and GABA by the ACH, you can't see just the control of all these three. So what happens if at all there is secretions of more and more ACH, you are not able to control the three neurotransmitters. So what happens? The dopamine may not be doing the enhancement activity. So this is the work of ACH. So the Parkinsonism can be done in two drugs, what is called anticholinergics. 1, to decrease your cholinergic activity, and 2, it is to increase your dopamine. That means the synthesis of dopamine can be increased, or the metabolisms can be decreased by two enzymes, COMT and MAOA, or MAOA and B, that we saw in the previous class. The synthesis of dopamine and the metabolism of dopamine, where it is done by two enzymes, what is called COMT and MAOA. So this is the cycle of dopamine traveling all over the brain, and where it has been obstructed by the decrease of substantia nigra and also the increase of ACH. So once the ACH has been increased in that total, and there is a dopamine deficiency into it, so you can't do the work of or control of both glutamate and GABAergic neurons. So what happens? You lead to Parkinsonism. Nothing but the sluggish movements of feet and hands, feet and limbs. So we'll continue in the next class about the classification and mechanism of actions in the next class. Bye for now.